Hi everyone. Today we want to talk about the lidar data and how to make the bed change map or differential maps. So I assume that you have enough information about the lidar data and the bed change or differential maps, but first we talk about how to convert the LAZ file to LAS and then convert LAS file to the raster file or DEM file or DEM format, and then how to make a bed change or differential map. I'm sure that you have enough information about the lidars, but you can easily search lidar on Google and have so many information about it. So as we know, lidar used a small aircraft or a small airplane like drones or other types of that, and took images like as you can see here, and then we can download it from different web pages and different sources, and then convert it to the bed changes and DEM files. So for example, this one is a one type of bed change. We want to see, for example, we have different images from different years, and we want to see what is the change of that. So one application is to detect the land use change. For example, we have two satellite image or two DEM file from lidar for 2 years, and we want to see, for example, the urban area and the vegetation area change during these specific years. Another option that we work more with that, we want to see the bed change. How is the erosion and deposition, for example, in two different DEM files for different 2 years. You just easily can search them. For example, this one is another land use detection. You can see the change of various years for vegetation, for example, the Rai riverbed and different things. And or for example, I showed this one in HecRas, but this is a bed change map that we produced or we made by the Arcmap. You can see the change of the bed topography. The white one is 0 and the blue one is deposition and the red one is erosion. So for this purpose, we have some data that we can download it. And for other countries, and we have so many source of data that you can find them in YouTube, or in your case, you can find it in your country. So just to briefly explain this web page, for example, you search NV LiDAR 2018, and then you have this area, and also you can choose to show it and other options that you have, which are very easy to understand, and I'm sure you can handle it. And then just go to the menu and go to the export, and then you have different options. You can save it as a point data, as a DTM, as a DOM, and other things. So for the DTM, you can export it as a DEM file, but for the point sky or the point data, you can choose this one, and you can see you can also option this. For example, we just want the data for the NV Lardal 2018. And there are some other options. So here you can see the file format. For example, we have LAZ and we have ZLAS. So generally the LAZ is a compressed format of LAS. So for a large area that we have so many files, saving LAS, it's really massive and we should use LAZ. And sometimes, for example, for this website also, it's impossible to download a huge amount of data in LAS. So it is easier to save it as a LAZ, and then we can use the coordinate system and other thing, and then prepare to export. And after that, you can write your email, and then you receive the data, a link of downloading the data by email immediately. So after downloading the data and receiving the data, I can show you here. You can see we have so many LIZ data here. So we download these data and we want to decompress it or convert it to the LAS that we can work with Arcmap, Arcgis, and other software to transfer it to them. So for this purpose, one tool is downloading the LAS tool. You just need to write LAS tools and for example this one, and then you have source files here, for example, and here you can download binaries, download with or without installer. It's directly go to this new page. You can choose Windows and download it here. And then go to the files. This is the LAS tools. If you open it, you have an Arcgis toolbox. So one option is go to the Arcgis softwares, Arcmap, and then from the tools, import this tool or add this toolbox. The other option is you can go to the bin and find your data, for example, LAS zip. You can find your .exe file. I can also search it here, LAS zip. Here is the file. So this is on the compress file. So I just go to the directory that I have it, or you can open the Arcmap. And here you have an Arc toolbox. And you can right click and add toolbox and go to the location that you have. So I unzip the files here, and in Arcgis toolbox, you can add these toolbox. And You can see LAS tools here. And then if you open it, you can open it here, the LAS zip. You have different formats. And just add your input file, the LAZ file, and then choose the output and continue these easy steps and then OK. You can also check the environment if you want to go in more details and then OK. But if we want to just directly open it from the downloaded file that we have it here, you should go to the bin and then LAS zip, for example. So we should go to the browse and then choose the directory and your folder. As you can see, we have so many LAZ files. So to choose all of them here, start.laz means that you can consider all the LAZ files. So, and by clicking, you can choose which one you want to check. So, as I want to merge all the LAZ files to one LAS file, I tick the merge files into one and then go to the input and choose the directory that you want. I use the current and you can see the name is merge.laz. And here for decompress, I choose the LAS and then decompress. Here again, start. So you should wait a little, and if everything is correct, then you can see the LAS file in the folder that you choose. Here you can see merged LAS. So now we choose the LAS file, and after that, we want to make the raster file or make the DEM file from the LAS file. So first we download the LAZ data and then convert the LAZ data to LAS. And now we want to make a raster data or DEM files from the LAS file by using the Arcmap. So here we are going to the folder that we have and then right click on this and go to the new and LAS data set and name it. I name it like this. And of course, before that, you should go to the new and start a new project. And then open this file, go to the files, add file, and you should add your LAS file. Open. So you can see here the number of points and other information, the minimum of the Z value and the maximum of the Z value. And then you can go to the statistics and calculate. It takes a little time, depends on your data. So okay. Okay, we can see the returns, the first return, the last return, the point count, and the values of the Z here, the name of the classes, classifications here. You can see the different detail. And in the general, you can see more details in the XY coordinate system, and then Z coordinate system, which I will explain it later if necessary. If you need to change the coordinate system, then use these, otherwise it should be fine. Okay, so then we should go to the geoprocessing and search for tools. And here, make LIS data. We open this. So here you can see the input. It's optional. You can choose based on the class code or based on the return values. It depends to your application. For example, if you want to detect the vegetation, you should choose a specific, for example, return values, or I just choose the last return. You can also see a little explanation here, or if you go to the help, you can find more details. You can also go to the environment and check different things, for example, XY resolution and other parameters if you want to do everything as best as possible. So you should also define these values here. And then, okay. So you can see we have a green tick here, and then it's good. And you see the results here. Then we should go to the tools and convert the LAS file to the raster. So LAS dataset to raster here. So we choose the file that we have. And for the output raster, you can change it or just keep like this. As I use the network, I have to keep it like this. And then the value field is elevation. You can choose other things, but I need the elevation. And the interpolation type, you can use the cell assignment type as average, or for example, IDW, which is the inverse distance weight. For the average in your pixel, it consider the average values for the pixel, and for the other type, you can also read it here. As, for example, for the minimum, assign the minimum value found in the points with the cell. For the IDW, uses inverse distance weighted interpolation to determine the cell value. As I like the use the weighted value, so I choose IDW. And for the void fill method, you can use different things, but I keep it as the default linear. And here, float and cell size and the sampling value. It depends to the resolution of the images or the LAS files that you have, or the lidar data that you have. but generally sampling value of 10 is high and gives you a low resolution. So I convert it to 0.1 and the Z factor is 1. So then you can go to the environments and change something there, or just okay. And you can see it takes some time, especially for my data which are for a huge area. It takes some time. So I pause it now. After finish this, I explain more. So now we make the dem file or raster file. Now we want to make a bed change map or a change detection or differential map that I explained at the beginning of this video. For that, you can use Arcmap or Arcgis Pro. Both are the same, but according to my license that I have, I use Arcgis Pro. For that, we should make a new project. I name it because I want to find the bed change map from 2018 to 2017. And then so then we should add to the file that we have. One is the 2017 and the other one just to be sure that the coordinate system of both them file are the same. If not, you can go to the properties and then source and a special reference and change it or check it here. So then we need tools. For that, you need to go to the spatial analyze and then map algebra and then raster calculation. I just directly write here raster calculator. And here you can see we have two. I want to have a 2018 as a benchmark and then minus 2017. And then the output raster is this, and then we can save the data. And you can see the data here. So it takes a lot of time. So I just pause the video, but now you can see we have the bed change here, this file. I can zoom to layer. And also change the color. it's a little massive, so it takes more time to see the files. But the next step for watching the correct bed change, you have to put the 0 value or white value for the no bed change. So you should change this area. For example, instead of a stretch, we can use the classify, for example. And then work with this. So it should be the exact -1 to +1 or -2 to +2. But as a symbol, you can understand how should be the legend. And for example, I can zoom here. So the 0 or the white values are without any change, and the blue one are deposition, and the red one are the scoring and erosion. There are also other way to define the bed change or differential change map, or using other functions, other tools that you can find them in the other references.